Welcome to the Ohio Lake Management Society's Lake Monitoring online tutorial sponsored by the Citizen Lake Awareness and Monitoring Program, also known as CLAM. Through education that promotes stewardship and preventing non-point source pollution, CLAM strives to care for Ohio lakes and their watersheds. Unlike pollution from industry and sewage treatment plants, non-point source pollution comes from many sources. When rainfall or snow melt moves over the land, it picks up and carries away natural and human-made pollutants and then deposits them into lakes, rivers, wetlands, coastal waters, and even our underground sources of drinking water. Some of these pollutants include fertilizers, herbicides, and insecticides from agricultural lands and urban lawns, oil, grease, and toxic chemicals from residential areas, sediment from improperly managed construction sites, from crops and forested lands, as well as eroding stream banks, and also as bacteria and nutrients from livestock, pet waste, and faulty septic systems. Non-point source pollution is difficult to see and measure, but it is the primary threat to clean water. CLAM enables the public to take an active role in learning about water quality and pollution prevention. Trained citizens gather vital water quality data to document changing lake conditions. This information is used in water management efforts by local partnerships made up of governmental agencies and community leaders. CLAM is also an excellent networking opportunity for concerned citizens and environmental groups. The Ohio Lake Management Society, or OLMS, Ohio State University Extension, and the Ohio Environmental Protection Agency are working together to provide training for volunteers. These volunteers enter a certification process to become qualified data collectors, or QDCs. OLMS provides technical support, equipment, data collection, and quality control for this statewide program. One of the goals of the program is to train citizen volunteers to do basic lake quality monitoring. 3 of the most common measurements taken are water transparency using a Secchi disc, water color, and water temperature. With this information, we can start to compile a record of the lake, allowing us to explore the conditions of the lake over time using baseline information to document any changes in lake water quality. This will determine what management techniques, if any, should be used and if they are working. Water transparency is one of the easiest measurements to gather, and it provides valuable information on the clarity of the water column. The Secchi disc is a simple scientific instrument named after an astronomer who measured the transparency of the Mediterranean in 1865. The disc is 8 inches in diameter and has alternating black and white quadrants. It is attached to a non-stretchable rope so that it can be suspended in the water column to observe how cloudy or clear the water is by viewing the depth at which it disappears. Transparency can tell us about the amount of sediment in the water. Sediment is the largest water pollutant by volume in the United States. It is brought into the lake from a variety of sources, such as erosion or in rainwater runoff from over the land's surface. In a shallow lake, winds can mix the water, causing the sediment to resuspend off the lake bottom. Rough fish, such as carp and bullheads, will often stir up the sediment while searching for food. When sediment is suspended in the water, it gives the water a muddy or cloudy appearance and reduces the water transparency. Secchi disc depth can also be affected by dissolved color or algae in the water. Dissolved water color comes from the decay of plants, especially woody material in the watersheds and from the lake itself. Small lakes surrounded by a forested watershed or small bogs may have water deeply stained brown. Microscopic plants called algae are an important part of the food web in a lake, but at high densities, algae will also reduce the Secchi depth. Determining the water color can indicate whether a low transparency is caused by algae or suspended sediment. If the lake has a small Secchi depth reading and a green color, we know that algae are reducing the water transparency. If the lake is a muddy brown color, then sediment is causing a reduced water clarity. Conversely, if the lake has a relatively large transparency but it is brown in color, then the lake may be influenced by dissolved color, suggesting a lot of decaying material. The third data point collected by CLAM volunteers is water temperature. Seasonal differences can be seen over the monitoring season. Year-to-year values as a baseline can be tracked so that unusual temperature readings can be investigated. In addition, volunteers record information on wind, cloud cover, lake usage, indicators of pollution problems, and any lake management efforts such as herbicides, dredging, or weed harvesting. As a CLAM monitor, you would collect data during the first and third weeks of each month, May through October, between the hours of 10 a.m. and 2 p.m. Try to allow a 2-week period or at least 10 days between sampling dates to get an overall view of conditions during the month. Attempt to monitor on bright, calm days whenever possible to increase consistency by minimizing the variables that would influence the results. When you are selecting the location of a sampling site, it is recommended that you have a map available showing the different depths of the lake. The first sample site should be at the deepest part of the lake. If you cannot obtain a map, the deepest part of a reservoir will usually be near the dam. The second and third sites are optional for smaller lakes and ponds. If you would like to collect data at additional sample sites for the larger lakes, you are encouraged to do so. These additional sites could be located near the headwaters, the center of the lake, in large coves, or other branches of the lake. If 2 people monitor the same lake, each monitor can sample a different site or be an alternate in the event that someone is unable to sample. Your personal safety is our primary concern. Be sure to follow all boat safety rules when taking readings. Do not go out onto the lake if it is raining or if the weather even suggests that it might rain. Lightning, high winds, waves, and limited visibility are safety concerns. Secchi disc readings should be taken on clear or partly cloudy days only, since clouds may cause incorrect readings. Do not take readings if heavy boat traffic or lake users such as water skiers or jet skis could put you at risk. And as always, wear your life jacket even if you can swim. It is important that the Secchi disc depth readings be taken in the same location each time. Using landmarks to locate a position on a lake is called triangulation. This technique will assist you in locating the same sampling site, or if you are able, plant a buoy at that spot. Buoys are not, however, recommended for public lakes. The first time you are out on the lake, use a map to help you locate the sampling site. Once you have located the site, look for several landmarks to help you find the site the next time. Try to locate at least 3 different landmarks and write them down, or better yet, draw a map. The lake monitor in this illustration is triangulating his position by lining up the tops of 2 houses in one direction with the lineup of the house and power poles in the other. When all 4 objects are in line, the monitor is over the sampling site. Always anchor your boat. You need to do so to prevent drifting and get good readings at the appropriate site location. Be careful about the stability of your boat. If possible, don't use a canoe or flat-bottom boat because they are unstable and prone to tipping. Take along a friend. Use the buddy system so that if something happens, there will be someone there to help. Be careful not to disturb the sediments on the bottom when anchoring, since this could cloud the water and interfere with the Secchi disc readings, especially in shallow lakes. Once you are properly anchored at the sampling site, move to the shady side of the boat, and if you are wearing sunglasses, remove them. To take the water temperature, lower the container from your equipment bag upside down to 1 foot below the water level, then tip it upwards to fill it with water at that depth. Bring the container out of the water and insert the thermometer into the container and place it in the shade. Wait about 2 minutes and read the thermometer without removing it from the water. Record the temperature on the data sheet in degrees Fahrenheit. The operation of the Secchi disc is simple. Lower the disc until the disc just disappears from your sight. Where the disc disappears, mark the rope at the water level with a clothespin. Then, lower the disc about another foot. Slowly raise the disc up until it reappears. Mark the rope at this water level with the other clothespin. To calculate the Secchi depth number, measure to the point 1/2 the distance between the point of disc disappearance and the point where it reappears. In other words, the midpoint between the two clothespins. To find this midpoint, grasp both clothespins together in one hand and find the center of the loop of the rope. Mark this midpoint with one of the clothespins and remove the other. Now measure the distance from the clothespin to the disc. Record the Secchi depth on your data card to the nearest inch. The Ohio EPA form requires 2 Secchi readings, and the average of the 2 readings are then recorded. To estimate water color, lower the Secchi disc to 1/2 the calculated Secchi disc depth. Describe the color by placing the color strip at the water surface and compare the color chart against the white quadrants of the Secchi disc. Record the number for the best color estimation. You can then use the Secchi disc to find the water depth. This depth should be about the same each time you sample. If the depth is different by over 2 feet, check your landmarks to make sure you have triangulated to the proper location. Remember that heavy rains or lake level drawdown as a management tool can change the lake level and affect the water depth. Lower the Secchi disc to the bottom and read the water depth from the marks on the rope. Record the depth to the nearest 1/2 foot. Do not measure the water depth before you measure transparency because the disc will disturb the bottom mud and ruin your Secchi disc readings. Except for the specific site data such as Secchi depth and water temperature and water color, please try to fill in as much information as possible on the data entry sheets before even leaving the shore. Put your name and Qualified Data Collector Number, or QDC, as the trained monitor onto the data sheet. Do not put the name of any non-QDC guests on the form. Include the lake name, county, sampling date and time, and latitude and longitude if available. Record the qualitative information such as cloud cover, recent rainfall events, wind direction, any lake management practices being done such as harvesting, dredging, or chemicals, and also determine the water quality with respect to algae, weeds, trash, and lake use. Record the type of waves at the site using 1 through 4, which is not inches or feet, but a representation shown by the guidelines on the data form between calm and white caps. Some reservoirs have a lake level or gauge located at the dam. If there is a gauge at your lake, record the lake level to the nearest 100th of a foot, which is 2 decimal places. Even a small change in water level can mean a large change in the water volume of the lake. Record any miscellaneous information you may consider important. Copy the information onto the summary form for your records, and then send the forms in at the end of July and October. Please be as consistent as possible on each lake monitoring visit. Consistency is making sure equipment is functional and calibrated. Your preparations, monitoring schedule, and location should be consistent, as well as data collection, methods, and protocols should always remain the same to minimize data error. You can submit your data online through the OLMS website by following the CLAM link. You may also mail your data forms to OLMS if you prefer. OLMS will provide you with reports of the data you have collected. You can use these reports to help see trends in the health of your lake. We welcome you as a CLAM monitor. To volunteer or for answers to any questions you may have, please contact one of our staff members. You may also visit the OLMS website at www.olms.org for additional information on the Citizen Lake Awareness and Monitoring Program. Funding for developing this tutorial was provided by the Ohio Environmental Protection Agency through a grant received from the Ohio Environmental Education Fund.